my screen. So Susie, how does it look?
It looks perfect.
It looked perfect. Okay, good. Oh,
It
there's
does.
Dr. Dada. He made it. We were waiting for you, Dr. Dada.
Can I begin my presentation?
So I want to minimize this. All right, Susie, you can still see the screen okay. You can still hear me okay, and you can see Wyatt.
Yeah.
We're still good to go,
Yes.
Susie? Okay.
Yep.
Great.
I can see everything. We're good to go.
All right.
Awesome.
Oh, shut off both lights so we can.
Professor Fredline?
Yeah.
You're going to need to turn the computer back a little bit towards the screen again. I think it moved.
Is that better?
That's better. There you go.
Thanks, Susie.
Awesome. Hi, everyone. Thanks for coming out. I'm Wyatt. This is my master's presentation. And I used Bayesian analysis to try to predict, keyword try to predict, the 2024 US presidential election. Here's some background information in case you are unsure how elections work in the United States. So every political party in the United States can elect a representative to run for president every 4 years. The US has two main political parties, the Democrats and the Republicans. The rest usually do not get enough votes to even be considered in the election. So they were not really considered in my model. In this case, the Democrats chose to elect Kamala Harris as their representative, and the Republicans chose Donald Trump as their representative. So each of the 50 states have a certain number of electoral votes. Can you even, yeah, you can't see the mouse. I should probably not move it. Sorry, each of the 50 states have a certain number of electoral votes, which are a combination of their Senate seats plus their number of seats in the House of Representatives. With the exception of DC, the capital, they only have 3 electoral votes, but they're not considered a state. So each state sort of has a separate population where whichever candidate gets the most votes in each state will win that state's electoral votes. With a couple exceptions, Maine and Nebraska, whoever wins the full state, they're going to get 2 electoral votes. And then they also have additional districts where whoever wins that district will get an additional electoral vote. So this past election cycle, Kamala Harris got 3 votes from Maine, and Donald Trump got 1 vote from Maine, just because of how it all works out. But all the rest of the states, it's winner takes all. They're going to get those electoral votes if they win. So in total, we have 50 states, 3 Nebraska districts, 2 Maine districts, and DC. So we have 56 districts that we have to predict. That totals up to 538 electoral votes, meaning that if a candidate gets 270 votes, then they will be the next president. Some more background info. Historically, many states can be predicted with extreme confidence. So here's some examples. California has voted for whoever the Democratic candidate is for the past 9 election cycles since 1992. And Kentucky has voted Republican for the past 6 election cycles. We don't really have any reason to think that these states would drastically change their views. So we are pretty confident in how they're going to vote. But we'll get to more of that later. But other states have a highly contested outcome. If a highly contested outcome has enough electoral votes to swing an election, then these states are called swing states. Shown on the map over here, I highlighted them purple because it's in between red and blue. I thought it was cool. The key swing states in the 2024 election cycle are Nevada, Arizona, Georgia, North Carolina, Pennsylvania, Michigan, and Wisconsin. So those are the states we're going to be keeping a close eye on throughout all my predictions and stuff. So here is the model that I'm going to use for my prediction. Here we start with just the base Bayesian modeling formula, where we get a posterior distribution that's proportional to some prior distribution times likelihood information. So we're going to start with some sort of prior information and then use some sort of data as likelihood information to update that prior, giving us a posterior distribution. So in this case, the prior is going to be a beta distribution with parameters alpha and beta. The beta distribution is a good choice because it measures proportions and it falls between 0 and 1. These parameters are calculated such that the variance remains constant, and the mean is the proportion of Trump voters. So throughout this model, I sort of eliminated all other candidates. So we are just going to be focusing on Kamala Harris and Donald Trump. So whatever the mean of this prior distribution is, that's going to be whatever the proportion of voters that Donald Trump got in the last election. And here we have just the formula, the prior distribution for each PI. Everything is sub I because it's on a state-by-state basis. Is going to be a beta distribution with parameters alpha and beta. So we're going to update our prior beliefs with pre-election polling data. This data, once adjusted, will contain a number of successes and a total sample size, describing a binomial likelihood function. Formula is down here. Essentially, given data that we know comes from a binomial distribution, this likelihood function will tell us which proportions in that binomial distribution are likely to give us that outcome. Also, I'm not adjusting polling data. I'm just taking it and removing the other candidates, which I'll get to in a moment. So then, since this prior distribution is conjugate to the likelihood function, this results in a posterior that's super easy to calculate. It just follows another beta distribution with updated parameters, alpha plus y, and then beta plus sample size minus number of successes. And again, that's all sub I because we're doing it for every state. So then this formula will provide the distribution of the two-party share of Trump voters. So here we have some examples. I'm going to get more into these examples in a minute, but on the x-axis, we have the proportion for Trump. Anything on the right side is in red because that means Trump wins, and anything on the left means that Harris will win, so it's color blue. And we can see how we get more, as we get more information, we get more confident in what our result's going to be, so our distribution narrows. So here are the prior parameter formulas. Alpha I, beta I, those are the prior parameters. The expected value of the prior is going to be whatever proportion that Trump won in the 2020 election. And we're going to multiply it by this sum, which essentially is going to calculate the weight that the prior distribution is going to have in the model. So that's calculated here. Essentially, we just used these formulas, plugged them into the variance equation. So now we can set a variance to calculate the sum for each state. And the variance is set to 0.001 due to our high certainty of the prior election data and lack of polling data in some cases, which I, again, will get to in a moment. Now that we have the actual results, it's possible that we could further optimize this number for future predictions. So I decided to go with two separate analysis procedures. One of them, I just calculate the mode, and that is going to be whatever value is most likely to happen. So for example, here we have the posterior distribution for Arizona. I highlighted the mode with a black dotted line. As we can see, it's just sort of the peak of the distribution. So that would be the value that I think, this will be the proportion of people who vote for Trump for Arizona that I think is most likely to happen, rather than the model thinks. And then I decided to go a different route, calculating the probabilities and simulations. So essentially on that, with this analysis method, I use this distribution to calculate the probability that Donald Trump will win each state. And that's just going to be the area of the red here. So I know that formula looks scary, but it's just the area of the red. And I definitely did not code that formula. R just has a built-in function that lets you do it automatically. Simulations done by choosing a probability from each posterior and seeing how it compares to 0.5. So as we start to simulate the election, we'll take each of these distributions. We sort of think that any of these can happen any of these values in the distribution can happen. So we're just going to pick one from each state. If it's greater than 0.5, then Donald Trump will get the electoral votes. If it's less than that, then he won't. And we're going to add them all up. And my computer can handle 75,000 of those, but we'll get to that in a minute. So here, data collection, my prior proportion. So this data was provided by the American Presidency Project, which is a project from the University of California, the Santa Barbara region. This data set contains every vote for every possible candidate in the 2020 election. Problem, we don't really care about other candidates besides the Democrat and Republican candidate in our model. In order to sort of get rid of those people as options and to make our data binary, I use these formulas. Mono votes equals Biden votes plus Trump votes. So I guess in Alabama, we had that many people who voted for either Biden or Trump. And then in order to find the proportion of Trump voters, I just took the number of votes and divided it by the model votes. Okay, so here's how I collected the data for the likelihood polling. I used a website called 538, a well-known polling aggregator. They collect every poll released on a state basis. So I could type 538/polling/Michigan, and it'll show me every poll that was conducted in Michigan throughout this election. However, this website only showed the polling percentages and the sample size. But in order to use our likelihood data, we had to have a number of successes and a sample size. So I had to, again, do some formulas. They often gave more options on their polls as well, and only expressed the results with a sample size of 2 percentages. So again, I had to figure out what percentage of people are only going to cast their vote for Harris or Trump. I found that probability of two-party, or the proportion of two-party, sorry. Then I had to adjust the sample size according to that. So we're sort of reverse engineering the poll. Some pollsters were very kind and they actually provided that, so I could just enter that. But a lot of them did not. However, some states did not have any polls conducted. So as before, like I said, Kentucky has been a red state, as they say, for the last 6 election cycles. And there's no reason that they think it's going to change. So I guess polling Kentucky would sort of be a waste of resources. Some people might call it that. So in those states, we just are predicting the election based on the prior knowledge. And these proportions are far enough away from 0.5 that it's not really going to mess with our model at all. So in terms of the actual proportion, it's not going to be as accurate, but in terms of the election result, it's not going to change much. So then here's a demonstration for the great state of Ohio. We have our prior information. The American Presidency Project says, after I did my formulas, says that 0.541 of the population voted for Trump. Using the formula, we got this sum, this S of 247.833. So then that leads us to this prior distribution here with these parameters, and that's shown down here. So this is just the same prior that we had in the other slide. So then our likelihood data, poll from Atlas Intel released on November 4th, the day before the election, pretty recent, has a full sample size of 1,022, Trump at 0.535, and Harris at 0.446. So again, we have to reverse engineer the poll. And I also rounded these numbers. I forgot to say that. I rounded these numbers. So we have Y equals 547 and the Ohio sample size to be 1,002. And again, that sample size is just taking out all the other options that the polls presented. So that gives us this posterior distribution. I don't know why that moved over here. Sorry. But the probability of, rather the proportion of voters given the sample, or rather given the likelihood information. Again, we see it tighten. We're more confident in the value over here. And we're given a mode of 0.54496. So we think, rather the model thinks that 0.54496 of, rather a proportion of that, of Ohio voters are going to vote for Trump. And also, I didn't really feel the need to put the calculation for the for the probability of Trump winning Ohio, because you can very clearly tell it is almost entirely red. So the probability of Trump winning Ohio is just 1. And he ended up winning Ohio in the end. So I guess we got some states right. Okay, so now we're getting into some limitations of this method. So again, like I said many times, it only considers 2 candidates. So a model like this would not work if we were to try to extrapolate it to like an election in Great Britain, where they have like 5 different parties. This model treats each state or district as an independent entity. So spatial trends are not considered, partially because when I started making this model, I didn't even know that that was a thing until I took Dr. E's class this semester. This also does not account for districts inside of states, so sharing a similar population. So like Nebraska's 1st district is really just a subset of Nebraska as a whole. This model does not account for that. Also, this model does not account for changes in voting history throughout time. So it only uses polling data from 2020 and pre-election 2024 polling. It does not even think about 2016, 2012, 2008, whatever. And then last limitation, polling data is taken as presented from only one source. So this, I would say, is our largest limitation. I did not introduce any polling average scheme. I just went through and I picked whichever poll was the highest. I didn't even mention that, actually. Let me go back. So over here is a list of pollsters on 538. 538 ranks them based on some ratings. They go down pretty low, but these are just the top. Worth noting, the #1 rated pollster is the New York Times. They're going to end up being the villain in this story, but that's okay. But we have some other ones up here, like Emerson College. I ended up using polls from all these places. So anyway, sorry, I forgot to mention that. So then I would just end up going on that website, like 538.com/polling/Michigan, and I would pick a poll from Michigan, and then I would put that in the model. So no polling averages were used at all. I think that would probably be the first thing that I would have changed about this model had I had the time. So yeah, as I can keep saying, pollsters could be biased due to the randomness of the data. No pollster is going to accurately predict what's going to happen. Follows the distribution of some kind, so we know that it's going to be random in some way. And this data does not, or rather this model does not account for a national trend. So any sort of blue wave or red wave was not sort of thought about at all in this model. Okay, so now we get to the part that took me by far the longest to figure out, how to do all the ggplot2 and using R and figuring out all that stuff. But here are the results of this model. So this model had Harris winning at 308 and Trump getting 230. As we can see, we had Harris winning 6 out of the 7 swing states. And I don't know, I guess I'll just let you guys look at it for a second while I take a drink of water. We can also see the model very easily predicted California and Kentucky, those states I mentioned earlier, where we sort of knew how they were going to vote already. So this model definitely used the prior information very well, I guess is a good way of putting that. Also, I put up here the additional districts in DC. DC had 4% Trump support in the model. That seems kind of crazy, but DC is just a city, so it makes sense. But notice how close all these swing state proportions are. 49, 49.5. They rounded up from like 0.496 or something. So we can see how close all of them really were. So we have a ton of uncertainty in our model. And that leads to this map, where I showed the probability of Trump winning each state. So all these ones, we're pretty confident Trump is going to take that easily. All the zeros, Trump is not going to take it easily, which means Harris is going to take it. Notice all the swing states, even though we had Harris taking all of them, there's still plenty of uncertainty. I guess the model says there's a 15% chance of Trump taking Nevada, which is what ended up happening. And we also have 31% chance of Trump taking North Carolina and 38% chance of Trump taking Georgia. Also worth noting, all of these districts in DC are pretty set in stone as well. So then that leads us into the simulations I mentioned, where we have just all the simulations I did. This dotted line here represents what a tie is. So anywhere on that side, we have Trump winning. Any simulations on this side, we have Harris winning. And I have a 95% credible interval shown in dark dotted lines here. So I suppose that the maximum electoral votes that my model predicted Trump would get is 295. Also, this value right here, this represents 308. Or rather, this is 308 electoral votes, which is the most likely map of outcomes that I showed earlier. But we have various combinations of outcomes that can lead to higher peaks. So for example, right here, this bar looks to be 292. That would be the case where Harris either loses, or excuse me, Trump either loses North Carolina or Trump loses Georgia, but would still win the other one. So those two are both combining to make a bar that appears taller, even though this is the most likely outcome, according to the map. Okay, so obviously this did not happen. Here is a comparison. So on the left, we have the actual results of the election, and on the right side, we have my model prediction. Trump winning with 312 in the actual, with Harris winning at 308 in my model. So notice how these maps overall look very similar to each other. Big differences, obviously Trump ended up taking all the swing states, whereas in my model, Harris took 6 of them. But notice how close the percentages are still. I mean, Wisconsin rounded down to 0.5. It was 0.49 before. Michigan is at 0.51, and it was at 0.5 before. So even though we got the election technically wrong, all of the proportions are still mostly correct. Mostly. Here we have a difference map. So this is going to be the actual results minus the predicted result. So positive values means that Trump performed better than we predicted, and negative values means that Trump did worse than we predicted. So notice it's pretty just red across the board, meaning that my model predicted Trump overall to do worse than he ended up doing. Some notable exceptions are, or not exceptions, some notable things are Minnesota with a negative 0.8. If I had to theorize, I think that might have something to do with the fact that Kamala Harris's running mate, Tim Walz, was from Minnesota. I know that gets people to vote for their candidate. Same with Ohio. J.D. Vance is also from Ohio, so we have a surplus there. Obviously, the most incorrect state we had, surprisingly, was Arkansas. Trump did 6% better than we expected him to. But the most surprising one, in my opinion, is New Jersey, with with Trump doing 5.7% better than we predicted. And this is pretty much the case across the board with all models. I don't think anyone could have predicted that. Here, I'll go back. I don't think anyone could have predicted Trump to get 47% of the vote in New Jersey. So anyway, some more interesting stuff. Polling data was pretty sparse up here. The only pollster really was the Northwest Progressive Institute, which by the name you can clearly tell is a left-leaning bias. So we did think that Harris did better than we predicted up there. Okay, and then here we have the simulations, just to sort of hammer it home. The probability of Trump performing as well or better than what he actually did according to my simulations is 0.001226666. So big question, what happened? Why did all this happen? Why were why was my model this incorrect? And I would say the biggest culprit is polling inaccuracies and turnout. So the New York Times released the results of a poll conducted in all swing states. They released it on November 2nd. Known for their accuracy, New York Times is the #1 rated pollster on 538. They did not nail it this time. They had Nevada, Harris winning by 3%, and notice how their little interval, Harris almost was on top of the interval. So I guess actually I'll keep talking about it. The New York Times had Harris taking 4 of the swing states, 2 of them tied, and Trump taking Arizona by like a lot, which is what ended up happening in Arizona. So that's good. However, it's easy to nitpick New York Times as being the culprit of the model, but I mean, if we look at the difference map, actually New York Times was pretty spot on, only off by about 1%, 1.4%. So I guess we had sort of polling inaccuracies across the board. The average difference was 2.06% in this model. So pollsters on average, or rather my model predicted Trump to do 2.06% worse than he did. So anyway, polling inaccuracies across the board, I think that was the main culprit. This can be fixed with, as I mentioned before, we could do polling averages. We could weight them based on how good of a pollster they tend to be. So that is a way to fix that. That would be the first thing to implement if I were to keep improving on this model. Continuing, this model also assumes no changes to voter turnout. So since the prior distribution is based on the 2020 election, that means we're also assuming the same voter turnout in this election, which was just an unrealistic expectation. Given the nature of this election, we had 2 assassination attempts. Kamala Harris only had 107 days to figure her stuff out. I mean, it was definitely very interesting. So it was probably very difficult for a politician to get people actually in the door to start voting. Rather, it was difficult for Kamala Harris to do that. I would imagine that it was a lot easier for Donald Trump to do that, given the assassination attempts. He was sort of seen as the beacon of freedom. Anyway, this was a very unrealistic expectation since 2020 had by far the highest voter turnout ever. It was over like 150 million people. Also, we did end up seeing the red wave. In order to incorporate this trend into the model, hi Frederick. In order to incorporate this trend into the model, a red wave or a blue wave, we would need to explore dynamic spatial temporal models, exploring interdependence between the states. These models could utilize data from many previous elections and also account for interdependence. I did not know about these models until long after I started this process. So in the future, I will definitely use that model instead. And then also another method that Dr. Dada proposed, use an underlying beta distribution to determine the baseline national trend, then use the logic to incorporate each state-specific trend. These could not be explored due to time limitations, but I think it would be a good way to sort of incorporate how the general American population is feeling about the candidates before actually making the state-specific trends. So, although my model didn't correctly predict the election, I still really enjoyed the creation process as well as visualizing the outcomes and comparisons. Creating these visualizations and interpretations are skills that I will take with me as I continue my journey into the realm of statistics. Thank you. Thank you.
Wyatt, if anyone asks you a question here, could you maybe paraphrase or repeat it
So yeah.
Okay, started. So he said that this was model for a binary choice election.
Mhm.
I think there is a not so difficult way of extending it to multi-party
Really?
Suppose you have three major viable candidates. How would you extend this beta binomial model for 3 candidates?
How would I?
Yes, keeping the other features unchanged, meaning your tires are siloed,
Mm-hmm.
right? Keeping those features unchanged, how would you explain?
I suppose you could run the model 3 times with each one having the proportion on the bottom, and then whoever has the most.
This is beta binomial, right?
Mm-hmm.
Suppose you have n candidates.
Yeah.
You could extend your beta binomial to Dirichlet multinomial. Dirichlet is a multivariate beta
Okay.
multinomial.
I'm sorry, I've never heard of that. But if you said it's a Dirichlet multinomial.
So multinomial likelihood,
Mm-hmm.
binomial likelihood comes.
Okay.
Instead of just one p, that's
Okay.
pk. And Dirichlet is just like a beta with a.
Okay.
Instead of just x power something, one x power something.
Yeah.
It's x1 power something. X power something. So that would be the most straightforward generalization. for
Yeah.
Multiple candidates.
Okay.
The component.
Yeah. That's interesting. Okay. Cool. Anyone have any more questions? Yeah.
Quick question, quick comment.
Mm-hmm.
As someone who's kind of seen this whole evolution of your project,
Yeah.
I think you did a very good job of explaining what I had the hardest part understanding, which is why you were wrong.
Mm-hmm.
You explained that very well. So, good job.
Awesome.
That's it. Just a comment.
Thank you. Yeah.
One comment, of course, this is one of those projects that everyone's interested in, right? I mean, you can tell there's a lot of people, probably this is one of the biggest turnouts we've had in a while for a presentation, a lot of people online. My suggestion is, yeah, this was your first stab and maybe the approach wasn't quite precise enough.
Mm-hmm.
But this is one of those projects that if you could probably continue working on and have a really nice project
Yeah.
in a year. So I just encourage you to consider,
I'm not just gonna drop it.
yeah.
2028, we're nailing it.
So that's my own suggestion. You pretty much, was jotting down questions as I was going along. You seemed to, answer all of them except maybe you answered, maybe you did, but Arkansas and New Jersey, why were you so off on those predictions?
That's a great question. I would, again, blame polls again. I mean, I really couldn't tell you. I guess these are states that are historically, New Jersey is historically a Democrat state, and Arkansas is historically a Republican state. But we did end up having polling data from them, so I guess maybe the pollsters weren't, they just weren't on the ball this time. Oh, really?
Eventually go
Hmm.
more powerfully.
True.
That's my
Yeah, that makes sense. I would guess that the pollsters just did not really have as much outreach into those populations that they might think.
Finally, I don't think you mentioned the people that responded to these polls
Mm-hmm.
probably weren't a perfect reflection of the population.
Yeah.
Right.
Probably not.
So I forget, chat about this for, I can't remember, Kurt, you said something with regards to the types of people that might respond to polls that, again, are more likely to respond, but don't. The aggregate at the end of the day didn't perfectly match the pop. So, I mean, that's just your, stat 101 fundamental, rule of sampling here. Sample should be a good reflection of the
Mhm.
population. So that's something.
I referenced that book in the paper.
What's that?
I referenced that book in the paper.
So what did you say, Kurt? I know you're sleeping.
I'm trying. So many things I thought about. Some populations. And Palestinian, Michigan, that as far as anybody else simply left out that had to take it. They didn't have any real motivation to vote parents because their positions on
True.
the whole situation in Palestine. And then obviously Trump wasn't going to help that cause there either. So significant populations, I think it was in Michigan and North Carolina, that as far as anybody else, simply just didn't vote.
Any online people? Ask if there's any online people have a question or comment.
Oh, I forgot to repeat all the questions. Sorry, online people. If you guys have any questions, wait, how do I see it?
So if you hit the escape button, maybe go to
This one?
right there, yeah.
Do you have any online questions? No online questions.
We're done.
Awesome.
Nice job, Wyatt.
Thank you. Thank you.